Alright, welcome back. Today we're going to be looking at experimental probability. Experimental probability is just, instead of the theoretical likelihood of something happening, we are going to be looking at the actual results of a trial. So, if we look at our first one, a coin is flipped 20 times, and we have our results. So first up, let's summarize our results. So, for our first one, if we add up and tally up all our results, we're going to get that heads occurs 11 times and tails occurs 9 times. Now, our experimental probability is going to be different from theoretical. So theoretical would have said there's a 50% chance of getting heads, 50% chance of getting tails. But in our experiment, we've got more heads than tails. So, what is the experimental probability of getting heads? So experimental of heads, it's equal to the number of times we're interested in happening. So in this case we have 11, it occurred 11 times, we got heads, divided by a total number of trials. So we flipped the coin 20 times, so we had 20 trials at this. And that's our probability. Okay, we usually leave it as a fraction. You can convert it to a decimal if you would like, but a fraction is usually our preferred method. So experimental probability in this case is 11 out of 20. Alright, B asks us, what is the experimental probability of getting tails? So our experimental prob of tails, what does this equal? Well, how many times did we get tails in our trials? We got it 9 total times out of a total 20 trials. So that's our experimental probability of getting tails. Now, let's quickly do C. Based on this experiment, how many heads would you expect in 100 flips? So our probability for heads was 11 out of 20. Now, if we repeated this 100 times, what we have essentially is an equivalent fraction. So we just need to work out how I've gotten from 20 to 100. Because it's gotten larger, I've clearly multiplied, and 20 times 5 is equal to 100. Now, for it to be an equivalent fraction, I have to do the same thing to the top. So 11 times 5 is equal to 55. So if I redid this, I would expect to get 55 heads based on this information. Alright, so this one here is one for you to practice. We have a marble being drawn from a bag randomly 20 times, and there are 3 different colors, red, green, and blue. So give this one a go, pause the video, and then I will solve it. Alright, let's get started. So for our first one A, we have to work out what an experimental probability of drawing a red marble is. So up the top, let's just put up how many reds we actually see. So if we count reds, we're going to get 8 red, and we have 6 blue, and we have 6 green. Okay, and we have a total of 20 trials. Alright, so what's the probability of drawing a red marble? Well, if there are 8 red marbles in there, and there was, if we did it 8 times, and out of a total of 20 trials, our probability is going to be 8 out of 20, which simplifies down to 2 out of 5. What is the probability of drawing a green marble? So the experimental probability of getting a green marble is going to be the amount of times we got a green marble in our trials, which is 6, divided by our total trials, which is 20, and that simplifies down to be 3 out of 10. Okay, let's look at C. Based on this experiment, how many green marbles would you expect to draw in 100 trials? So green was 6 out of 20 or 3 out of 10. So what we can do is we can put 3 out of 10 is equal to something out of 100. Now, to go from here to here, I've clearly multiplied by 10. I have to do the same thing to the top, so I maintain this proportion, and that becomes 30. So I'd expect to get 30 green. 30 green marbles. Alright, that's it for this video, so hope it was helpful, and I will see you in the next one.